this video, we are going to look at multiplying fractions, but this time I don't want us to use any of those models. Now, if you haven't watched the one with the models yet, go back, watch that one first so you get an understanding of where this comes from. So when you were watching the model ones, I hope that you noticed the pattern became very obvious, that really all we were doing was multiplying the two numerators together and multiplying the two denominators together. And really, multiplying fractions is just that simple. It's so nice. It's numerator times numerator and denominator times denominator. And oh my goodness, isn't that much easier than trying to find common denominators like adding and subtracting? So look how easy this is. 2 times 4 is 8. 3 times 5 is 15. Oh my goodness. All I need to know is my times table. Anyone can multiply two fractions together. I know you guys can do it. You're so smart. Okay? All right, let's do another one. This goes so fast, right? 4 over 7 times 1/2. Okay, so that's going to be 4 times 1 over top of 7 times 2, right? I multiply my two numerators. I multiply my two denominators. 4 times 1 is 4, and 7 times 2 is 14. Great. Now, I do see, I can put this question into lowest terms because both top and bottom have a common factor of 2. So I'm going to divide out that common factor of 2, and that gives me 2 over 7. Now, there's actually something nice we can do with fractions. So let's just go back a step here. Okay, so did you know that multiplication is what we call, and I think I've said this in lessons before, but multiplication is what we call commutative. And that means that our numbers are allowed to be multiplied in whatever order we like. So using that commutative property, I'm just going to do something a little bit crazy here, okay, to just show you how this works. I'm going to switch the places of 4 and 1, okay? So I still have the same multiplication because 1 times 4 is still the same thing as 4 times 1. I've just switched their spots, okay? So I went from 4 over 7 times 1 over 2 is the same thing as 4 times 1 over 7 times 2. I just flipped my 1 and my 4. Okay, now just hold on, bear with me for a second here. I'm going to do something a little bit crazy. I'm going to split these into different fractions here. So I'm going to split this, and I'm going to take those two first numbers and I'm going to write it as 1 over 7 times, and then my second fraction, I'm going to write it as 4 over 2. Okay, now I know that's a little bit crazy. Why in the heck is Mr. T doing this? It doesn't make any sense. I have good reasons. Okay, now look at this fraction right here, 4 over 2. I wouldn't write 4 over 2. That's crazy. No one's going to write 4 over 2. I'm going to put that into lowest terms, right? 4 over 2, they have a common factor of 2. So another way I would write that would actually probably be 2 over 1, right? Because I could divide 4 by 2 to get 2, and I could divide 2 by 2 to get 1. Well, now look at what's happened, because if I do that, now this is where things get really crazy. Mr. T, you're totally changing what it is that we're working on here. Now I'm working with, instead of 1 over 7 times 4 over 2, now it's 1 over 7 times 2 over 1, and it's still the same question, okay? Well, now when I do this, it's just 1 times 2, which is 2, and 7 times 1, which is 7. Wait a minute, 2 over 7? No way, that's what I got here. I got 2 over 7, I got the same thing. What in the heck happened? So what I did is, through the commutative property of multiplication, I'm doing something that we refer to as cross-reducing. So here's really what it looks like. What I have done is I've said, see this times here? It's like pointing at the numbers that are across from one another. And we say, in cross-reducing, we look at those numbers across from one another and we say, hey, if we can reduce those numbers before we multiply, we're going to reduce those numbers. Well, why? Because I'm allowed to reverse the order of my numbers, and I still have an equivalent expression. They're still the same thing. So if I reversed the order of the 4 and the 1 like this, I could put this into lowest terms as 2 over 1. Now, that's way too much work. I don't want you to write that out every time. That's crazy. No way. But what I want you to notice is, hey, 4 and 2 are across from each other. They could be put into lowest terms because they both have a common factor of 2. Let's take out that common factor of 2 from both numbers. So what I do is I write 4 divided by 2, and 4 divided by 2 equals 2. So instead of writing a 4, I'm going to write a 2. 2 divided by 2 is equal to 1. So instead of writing a 2, I'm going to write it as a 1. So now I've changed my expression to say, instead of it being 4 over 7, I now have 2 over 7. Okay, so now I have 2 over 7. Okay, and then I'm still multiplying. And instead of having 1/2, that 2 has changed also into a 1. And now my expression is simply 2 times 1, which is 2, and 7 times 1, which is 7. And that's what we're going to be doing is cross-reducing. So it's basically like putting our numbers into lowest terms before we multiply. That's actually really handy because then we're not going to get any giant numbers. So let's look at another one. Okay, I've got 8 over 15 times 5 over 16. And again, the x in my multiplication is saying, hey, Mr. T, please look at the numbers across from one another and see if you can reduce them. So between 8 and 16, I have a common factor of 8. If I take 8 and I divide by 8, I would rewrite that number as a 1. And 16 can also be divided by 8. 16 divided by 8 is a 2, so I can rewrite that number as a 2. Now, please, Mr. T, look at those numbers across from one another. But I can also look at these numbers that are across from one another too. I got the 5 and the 15, and both of those values are divisible by 5. 5 divided by 5 becomes a 1. 15 divided by 5 becomes a 3. So now I have put my question into lowest terms before doing any of the work. So now I'm really looking at, and let me rewrite what we have here. So I have 1 and 2, and I've got a 1 and a 3, and then I'll use white to fill in everything else that we had. So I've got 1 over 3 times 1 over 2. This is the exact same question that I just had. 1 times 1 is 1, and 3 times 2 is 6. Now, if you don't believe me, take some time to multiply this thing out here, right? So you could take some time and multiply it out. This is going to be really awful numbers, right? 8 times 5 gives me 40. 16 times 15 gives me 240. Ugh, well, these are giant numbers. And now to put this in lowest terms, this is kind of a pain in the butt. I don't really know all the biggest common factor here. But oh wait, I can see both numbers end in 0, right? Okay, good. If both numbers end in 0, then I can divide top and bottom by 10. So I divide top and bottom by 10, and now I get 4 over 24. And I go, okay, well, wait a minute, that's still, right? I can put that into lowest terms further because both top and bottom have a common factor of 4. Okay, let me get rid of that common factor of 4. And now I get 1 over 6. Wait, 1 over 6? Really? I already had 1 over 6. Doing your cross-reducing allows you to find common factors when the numbers are smaller. Look how big this number gets when I multiply 15 and 16. 240 is a giant number. I don't want to look for common factors between 40 and 240. Those numbers are so big. It's way easier to see common factors when you go back and you look at just 8 and 16 or 5 and 15. It's so much faster to find common factors that way. Now, you won't be wrong if you do it like this, but chances are you're going to have a harder time putting your answer into lowest terms than those of us who are going to cross-reduce. So I really want you to be practicing your cross-reducing. Oh, look at this. There's no way in the world I'm multiplying these two guys. Nuh-uh, not going to do it. Can't do it in my head. Too hard. Let's see if we can cross-reduce. Okay, that x is pointing at the numbers that are across from one another. Hey, Mr. T, can you reduce 27 and 54? And I go, wait a minute. 54 is 2 times bigger than 27. Oh my goodness, I can go 27 divided by 27, and that's going to turn into a 1. And 54 divided by 27 turns into a 2. Those are really easy numbers. Hey, wait, 35 and 49. They have a common factor of 7. Okay, let's use that common factor of 7. 35 divided by 7 gives me 5. 49 divided by 7 gives me 7. Oh my goodness, these are numbers I can work with. That's not a problem. I've now changed it to be 1 over 5 times 7 over 2. Well, 1 times 7 is 7, and 5 times 2 is 10. Look how ugly these numbers were. I had to go 35 times 54. No way. That number's going to be too big. I can't find common factors from that thing. But if I look at these numbers across from one another, I might be able to see some common factors when the numbers are smaller. Multiplication makes those numbers get very big very quickly. So if you can see common factors, get rid of them before you multiply. This is why I love multiplying versus adding, because the numbers can be simplified and it becomes so much faster. Okay, solve the following. Oh my goodness, I got 4 fractions multiplying together here. This is crazy. No way anyone can do this, right? Okay. I can still cross reduce. Now, I'm looking across at the 3 and the 2, nothing I can do there. I look across at the 1 and the 4, nothing I can do there. But as long as one of my numbers is in the numerator and the other number is in the denominator, I can cross reduce, because remember, multiplication is commutative. So all I would have to do is I could move the space of those 2 fractions. If I flipped the 1/2 and the 5/6, then the 3 and the 6 would be directly across from one another. So all that needs to happen is I need a number in the numerator can reduce with a number in the denominator. All right, well I can do that. 3 and 6, they have a common factor. 3 divided by 3 is 1. 6 divided by 3 is 2. I have another common factor. Look at this, 4 in the denominator, 8 in the numerator. Those guys have a common factor. They have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And would you look at that, I have another common factor. I have a 2 in the denominator and a 2 in the numerator. Those guys can also cross reduce. 2 divided by 2 is 1, and 2 divided by 2 is 1. Now, look at that. This number actually reduced twice, didn't it? I divided by 4, I got a 2, but that 2 could be reduced even further with this 2, so that's fine. You are allowed to reduce a number more than once. Now that this number is at 1, it can't reduce by anything else. Okay, so what started out as 4 fractions multiplying together has now become really easy. So look, this first fraction was 3/4, but now I'm going to write it as 1/1 because my other things have reduced. The second fraction was 1/2, but now it's 1/1. That's looking pretty simple. It's always easy to multiply by 1. The third fraction has now changed to be 5/2, so I write that as 5/2. And my last fraction has gone to be 1/9. So now when I look at this, I'm going to go numerator times numerator times numerator times numerator. 1 times 1 is 1, and then times by 5 is 5, and then times by 1 is still 5. It's not so bad. Okay, look at the denominator. 1 times 1 is 1, times 2 is 2, times 9 gives me 18. And there we go. My answer is already in lowest terms because I removed all the common factors before multiplying. If you didn't remove all your common factors, you can still get the right answer, but it's much harder to put into lowest terms. I'm going to be dealing with much bigger numbers that I then have to find common factors for, and it's harder to find common factors when the numbers are bigger. If you can, pull out as many factors before you multiply, and that's cross-reducing.